Hello everyone, my name is Daniel and today I'm going to present the job market data pipeline project. The idea of this project is to develop a data pipeline that aggregates information from various sources about the tech job market, and those sources will actually help tech workers make better decisions about the companies they want to work for. So the first source we're going to be using here for this project is the website teamblind.com. So this website is a famous social network, anonymous social network, where workers generally post information about the companies they work for. This website provides parameters, for example, like work-life balance, compensation, career growth, and much more. So we're going to be using Team Blind for that. In addition to that, we're going to be using Levels.fyi. This is a famous website that provides more information about company roles and levels. And within those levels, it provides information about compensation and offers. So we're able to know exactly how much a person in a specific level and in a specific city is making for that role. So it's a pretty useful source of information. And as you may imagine, if we cross this information from Levels.fyi with Team Blind, we have a very enhanced data source. Finally, we have an extra data set about climate within cities. So let's say you want to move to a specific city, but you also want to assess like if you're going to be comfortable in that city. So this data set will help us also make decisions about based on climate. So we can actually do very interesting queries with the merge of those three data sets. We can look with like for good work-life balance companies that also have, for example, good climate. That way, whenever you're going to the office or working, you're feeling comfortable. And plus, you can also look for the financial aspect with Levels.fyi. So you can look for specific compensation values. So yeah, we're going to derive that pipeline. So moving on here to the next slide. So in order to gather like a list of companies, we're going to use the Blind as our central spot to get a list of companies. Within Blind, we're able to scrape that by using their search feature. As soon as we have the list of companies, we're then able to look for company details. So within Blind, we're able to supply a company name, and we can get their overall score, career growth score, compensation and benefits, management, work-life balance, and company culture. So we get a lot of information, plus we get the location of the company, which will be useful to cross with the climate data set, size, when it was founded, the salary range. And this salary range is not very deep, so we're able to actually cross this information finally with Levels.fyi, where we get all the levels and the compensation, the TC, the total compensation, divided in base salary, stock, and bonus. And again, this is also derived by region, but this is an overall look of compensation per company and role. And finally, we have the data set from Kaggle with climate information, which will help us enhance those queries as well. So this is the project. Now we're going to jump to the architecture overview. All right, so let's cover the system design. So over here, we have a complete diagram of the solution. We're going to go starting from number 1 all the way to number 19. So on number 1, we just want to point out that this whole data pipeline will be executed with the help of Apache Airflow. So this is going to be a DAG, a directed acyclic graph, that will be executed by Airflow. If you're not familiar with Airflow, it's pretty much an open source solution for data pipelines, so you can write your data pipeline and orchestrate it. So we're going to be running inside using Apache Airflow. The first thing we're going to have within our DAG, our directed acyclic graph, is an operation, a task called start. This task will set the current time of execution of the DAG, so the month, day, and year. And from that point on, we're going to branch to 2 task groups. The first task group will download the historical climate data set, and that data set comes in CSV format. And this specific task will download it and convert it to Parquet and push it to S3. After that conversion and pushing it to S3 is done, then we have one more task that will validate that the data set is indeed in S3 and it's not empty. The second task group here, we have a first task that actually goes to teamblind.com, and that this task will be responsible for scraping all companies within Team Blind. So it's going to get all company names and if those companies are active or not in the platform. So we're going to be scraping all that company information here. Team Blind, as of the recording of this video, has about 70K, 68, 70K companies. So it's this scraping job doesn't take long. Like we're going to see that this whole pipeline can be easily executed in 10 to 12 hours. So we're going to get that company information. Also will come in Parquet. We're going to also save it in Parquet format for easy compression. And then we have a validate Team Blind companies list step, which will validate the file and validate that it has information inside of it. Finally, we're going to join those two task groups with this join get data operations. This is like a simple dummy operator. And from this one, we then are going to kick off two other task groups. And those are not going to run within Airflow. So previously, all those operations were running inside of Airflow using Airflow compute. Now, for those next two task groups, they're actually going to be running within Aws Batch. Aws Batch is pretty much a service within AWS that enables us to create a compute environment with a queue, and then we can specify how many pods or containers we want to be executing a specific job. So, for instance, like for this situation, we're going to create one job for Team Blind and another job for Levels.fyi. The job for Team Blind will have about 50 pods, and each pod will be running two separate threads to scrape information from the Team Blind's details page. And the second scraper here, the Levels.fyi, also will be run as a job within Aws Batch with 50 workers, and within and each worker will have two threads as well scraping. And so both of those tasks will be executing. This is pretty much where the pipeline spends most of its time. It's just waiting for all of those workers to finish scraping. Since we're talking about 60K to 70K companies total, because those scrapers will be running the company list that we scraped on step 5. Each worker will be dealing with about 600 to 700 companies, and that takes around each worker 10 to 12 hours to finish executing. In order to tunnel or traffic, each worker also communicates with a specific, each thread within a worker communicates to a specific proxy server to then tunnel the request to Team Blind or Levels.fyi. After this part is done, after Aws Batch finishes executing for Team Blind and Levels, we also have a validation step to verify that the Team Blind dataset, the details dataset for each company is there, and it should be saved in Parquet format as well. Same for the Levels.fyi, it's going to validate that the Parquet file for Levels.fyi is there as well. As soon as those two steps are done, then we kick off the final step, which is the EMR cluster, pretty much the ETL part of this pipeline. Here we're going to start by uploading a bootstrap script and an ETL script in Python so a bootstrap shell script and a Python ETL script to S3. Those scripts will be necessary for us to boot the EMR cluster. The bootstrap script from step 12 is used to install libraries and dependencies, and the script from step 13 will then be used to actually execute. Will be executed within the cluster. So we upload those scripts, we create the EMR cluster, it will bootstrap the cluster, then we add an EMR step, which pretty much the EMR step will ask EMR to run the ETL script as soon as the bootstrap process is done. And finally, the step will actually execute, and Airflow will wait for all the steps to be completed. And what those steps are actually doing is getting all those Parquet files, the Parquet file for historical climate data for all the Team Blind companies, and also the details for Levels.fyi and Team Blind. It will get those 4 Parquet tables and convert all of them into Delta tables. And Delta tables, Delta is a format that actually enables asset transactions over those Parquet files. So Delta is built on top of Parquet, but it also has it enables asset properties to it. So we can pretty much treat it as a database, as like a block storage offline database. So after the steps are done and all the data tables are stored, then we can terminate the cluster, and then we have a dummy operator that finishes the DAG. And then we have step 19, which means that now that we have the data, we can use a Jupyter Notebook and use those delta tables with Spark or Pandas, and we can query that information and gather the analysis that we asked in the first place. And that's pretty much it. We definitely have more details about the system design and about the data model inside the README file for this project, and that can be found, let me minimize here for a second, that can be found over here. So inside the Airflow folder for this project, we have the system design described here as well, but we also have the data model. So for each table that I just described, for example, the companies table, what are the data types that are being used, and an example instance of it. Same thing for the climate table, for the Levels.fyi table, and also for the team blind table as well. And we also have a full description about the source code and which what is which script doing actually. And yeah, that's it. So now that everything is done, we're going to jump to the demo, and we're going to see this pipeline in action from ground zero. Let's do it.
All right, to the demonstration we go. So first things first, we're going to open our terminal. Right here, I'm using WSL2 on Windows. This is pretty much like a Ubuntu virtual machine. So in case you're using Linux or Mac OS, you should be fine as well. Because most of this demonstration will run inside Docker containers anyways. So the first thing we need to do is I'm going to just navigate to my workspace, and I'm going to create a central folder called Job Market Pipeline. You can call it whatever you want, but I'm just going to call it that. And inside of this folder, I'm going to clone the two GitHub repos containing the source code that we need. So let me just open GitHub really quick, and within GitHub we should be able to click on the Job Market Pipeline project. We're going to start with Airflow here. We're going to just click over here, git clone this guy, and give a key. And the second one we're going to also clone inside of this folder is Terraform. So let's just click on Terraform really quick. Same thing, and we should also be able to clone Terraform. And there we have it. So now we have two folders inside of this. We can close this for now. And the second step now is to set up AWS, because we're going to be running the Terraform next. So actually, yeah, first things first, we need to verify that we have the AWS CLI installed. So you should type AWS version, and that will tell you if you have the CLI or not. If you don't have it, you need to install it. After installing the CLI, we need to do AWS Configure, and that will ask us for an AWS access key and secret. So we're going to now open AWS, and right now I'm set on US East 1 as a region. After that, we're going to click IAM and users. We're going to add a user right now. This user is going to be called Airflow, and we are going to access key. Yep, we need a key to access AWS programmatically. So next, and then in terms of permissions, we will actually attach a policy, and we're going to attach the administrator access policy. This policy will give us full access to all actions and resources within our account. It's a super powerful policy, so be aware this is mostly being used for this demonstration, but we're going to talk more about this later. Then tags, we're not going to tag this anything, and there you go. So we created a user, and after creating this user, we automatically have an access key that we can use. So we're going to paste it there, and also the secret. So, and also this will be deleted after the demo, so don't worry about it. There we go. The default region here is going to be US East 1. The output is going to be JSON, and we're good to go. If everything happened correctly, you should have an AWS credentials folder with a default profile here containing those credentials. Nice. So with AWS set up, now we are able to navigate to Airflow, and Airflow is going to be your central repository. If we open Visual Studio Code here, we should be able to see a README file. And inside this README file, we have full instructions about the project. I'm not going to go over the project overview. The system design we already covered, but here we have the data model as well, but we're going to actually take a look at the local setup. So the local setup will basically instruct us what we need to do in order to set up this project. So right now we need to go to the Terraform folder and follow the README there. So we're going to do that. So actually we're going to open Visual Studio Code again, but now we can access the Terraform folder, and we also have a README here. Let's just follow the README. So the first thing is install Terraform. Simple enough. So let's just check if we have Terraform version. Yeah, we do have Terraform installed, so that's good. In case you don't have it, just click on the link and follow the instructions. The second step here is to check dev TF-vars. So TF-vars stands for Terraform variables, and basically here we're going to establish our main variables that will be used while executing Terraform. The ones that really matter for us in this case is the bucket name, and the reason why is because like this Terraform pipeline, it will actually create a bucket for us. But buckets within Amazon S3, they have unique names. So if I run this right now and I use the name job market pipeline, it will probably work, but because nobody has a bucket with this name. However, like having unique names are necessary, right? So because I ran this already, this is already taken. So you should probably attach like one or two, or maybe put a different name altogether, right? So I'm going to stick with job market pipeline, but just be mindful to change this, and feel free to change it to anything. Also, other interesting properties that we can play with, and they are going to make more sense later, but is the number of virtual CPUs that we have for each Aws Batch compute environment. So right now we have 50 virtual CPUs for the Team Blind scraper and for the Levels.fyi scraper, but we can change this later, and we're going to talk more about it. All right, so going back to the instructions, we've checked, everything is looking good. Now we can just run init, and init will be responsible for downloading any necessary providers. So in this case here, we're using HashiCorp AWS. So init will actually download all the necessary source code for this provider. So let's just go over here, Terraform, and we're gonna run, not this one. We're gonna run this command here. So let me copy it again, and there we go. So now it's installing all the necessary modules. Nice. Okay, they were pretty much cached already, so it was pretty quick for me. The second step is we can plan to see what this pipeline will generate. So, sorry, what this Terraform module will actually generate for us, script. So let's just click plan. So it will run the Terraform script here and will let us know, like, hey, those are the resources there you're gonna provision in your AWS account. So I'm not going to go over this in much detail right now, but basically it is creating VPCs, the Internet Gateway, routing tables, subnets, AWS batch compute environments, queues, and much more. Yeah, but like basically you can see exactly what's going to be created within your AWS account. And that's great. So the plan shows us what's going to happen, but it doesn't actually execute it. In order to execute it, we need to do a Terraform Apply. So let's just do that right now. And Terraform Apply will probably run the plan again, and will let us know what's happening. Okay, so now it's basically asking, hey, do you want us to perform those actions and apply, create those resources in your account? Yes, let's do it. and now it's doing the creation process here. And again, we can see, yeah, it's also creating ECR repositories, a bunch of stuff that will be used by Aws Batch, more specifically. It's creating VPCs. And I'll cut the video here really quick, and I'll come back whenever this is done. All right, and now we're back. After executing, you should see a message like this one. So we completed adding all the 25 resources. If we go to Aws to double check it, we can navigate, for example, to the VPC section. And inside VPC, you should click on your VPCs. And over here, we basically can see that, yeah, the job market VPC was created. You should also have a default VPC. The default VPC will probably, it's going to be used for EMR. And the job market VPC will be used for Aws Batch. And yeah, you should see all those resources here, subnets, routing tables. And if you click on Aws Batch, you should also be able to see your job definition, job queues. They should all be there. So that's great. So it seems we have everything created. Now we're up for the next step. So after running this, we also need to create some IAM roles, default roles for EMR. So we're going to just copy this command here. It will create some default roles that we're going to use in our setup. And I probably already have them, but I'm going to run this anyways. Basically, create default roles returns an array with all the roles created within our Aws account. So that's it. Next up, we need to push Docker image to ECR. This Docker image is actually the one that is going to be used by Aws Batch. The first thing we need to do is to log into our ECR repository. Just be mindful to change the Aws account listed here to your own Aws account. To find your Aws account, you can just go on the top right corner of your dashboard. Let me show you. So over here, if you go to the right side, you should see your account ID over there. That's what you need to use over here. So let me close this. So we're going to copy this command really quickly. We're going to go back to our terminal here, and we're going to run it. So this will log in, we'll pretty much like log in Docker with this ECR repository. And after that, we're going to just copy this command right after. So this other command will build this Docker image and tag it as job market scraper. So let's do it. Again, this is the Docker image that will be used by Aws Batch. So we can just wait for the build process. Should be fairly quick. And meanwhile, we can copy the next command, which will tag. So this image is being tagged locally as job market scraper. We're gonna basically create a tag from job market scraper locally to this very specific one here that will be actually used by ECR. So let's go back to the terminal. And I'm gonna cut here. I'll be back in a second. All right, and now we should be able to run the last command. So actually the second one here, we're gonna retag this image. Again, be mindful to change your Aws account over here. Let's just copy paste this, nice. So actually if you type Docker images, you should see both of them there. The first one with the normal tag and the one with the ECR tag, the Aws ECR tag. And now we can finally just do a Docker push. Again, be mindful of the Aws account, and we should be good. So let's just push this there. Oh, sorry, gotta do Docker push. All right. And this will push the image to our private ECR repository. We can check that over here. So if we go to Aws and we look at Elastic Container Registry, we have the job market ECR repository, and within it we have no image tags, but we're pushing a tag right now, so we just need to wait for it. So the tag is called scraper. It's pushing, and I think if we refresh right now we should see it, and there we go. We have the scraper image there. That's great. So now moving forward, we finish all the instructions within Terraform. That means we pretty much provision all the resources in AWS that we need for now. So we can go back to the previous instructions, to the main Airflow README file. And over here, again, back to the instructions. Oh, sorry. We finished the Terraform setup. Now we need to set up Airflow Docker Compose. So this pretty much, let's just click here for a second. So this is a tutorial that explains how to run Airflow as a Docker Compose setup, pretty much a set of Docker containers. We don't need to follow this strictly. I actually left some of the most useful commands here because some of the stuff we already have, for example, the DAGs folder, logs, plugins, you're going to notice on the left side that we already have those folders as well. So pretty much we don't need to run all of this setup. So we're going to come here really quick and we're going to run those commands here. So we're going to run docker compose build. So let's just go to Airflow. There we go. In Docker Compose build, we'll build a custom image that we have located at Airflow custom image that will be used by our Airflow workers. This image actually contains some of the libraries, some extra libraries that we need in order to run our scripts, our Python scripts. So yeah, as you can see, it's actually doing pip install requirements, installing a bunch of requirements for us. Pretty much a custom image that will be used by the workers there. So let's just wait a little bit and this should be done. After that command, we're going to run docker compose up airflow init. So this will initialize Airflow for us. So Airflow actually contains a Redis and a Postgres database. So this runs all the database migrations that we need in order to run Airflow properly. We're going to run that next after this finishes executing. And I'm actually going to cut this now and come back in a second. All right, we're back once again. So now we can run the second command, which is docker compose airflow init to run all the database migrations. Let's do that right now. As you can see, it's putting up Postgres and Redis, and it's pulling the Docker images for those. So we can just wait a bit. And again, I'm going to cut the video because this is like a very extensive process, but I'll see you in a second. All right, it finished executing. You should see a message like this one by the end of it. Pretty much it created our Airflow default user, which we're going to use to log in into the Airflow dashboard, excuse me. So let's just go back here really quick and run docker compose up. That will actually run the whole setup for us. So let's just do that. And again, it's going to pull some images, and we're going to talk about the setup after it gets executed. So I'll cut here and I'll come back again. All right, so now the setup is up and running. Some important notes: as soon as we do docker compose up, it's obviously going to pull all the Docker images, and it's going to start executing the containers. One notable container is this PySpark container here, and it's going to output this specific path, which we should copy actually. Let's just copy it here really quick. And this PySpark container actually is a full-featured like Jupyter Notebook environment. We're going to use this later, but it's also important noting that it's there, and that's pretty much how you access it. However, now we are actually interested in Airflow, so I'm going to keep a tab on this, but I'm going to jump to the Airflow setup. You should see something like this, like all the containers are up and running. So right now, so port 8888 is the one that runs the Jupyter setup, but if we go to localhost 8080, that's where Airflow is. The username, as specified in the tutorial, is Airflow, and the password, and the password is Airflow as well. So let's just go back to the browser really quick. There we go. Oh, sorry. So we're going to type Airflow, and log in. And there we have it. We have Airflow pretty much up and running. However, we do have an import error issue here. We're going to fix that in a second. So the next step here is to set up a bunch of connections and variables within Airflow. So we're going to do that now. So the first thing is set up a connection called Aws Configure. So I'm going to just follow the tutorial. I'm going to put this on the side actually. And I will just do this step by step. So I'm going to navigate to connections. And let me open this here again, 1 second. There we go. Oh, yeah, okay. And we're gonna click plus here. We're gonna create a connection called Aws Con ID, which is gonna be our Aws connection ID. We're gonna select Amazon Web Services. And over here, we need to put our login and password that represents our access key and secret. So we're gonna open our terminal really quick to catch those. You can do cat Aws credentials. We're gonna copy the access key here as the login, and we're gonna copy the secret as well. So we're gonna do that, okay. And there you go, and save. So this is our first one. The second one is, oh yeah, and within the connection ID, we also need to add an extra step, which is the region name. So the region name that we are running, we're going to be running with those credentials. So we're going to be running at US East 1. There we go, save. Second variable is the S3 connection ID. There we go. And here we're going to be using Amazon S3. So for this one, you could also use different credentials. I'm going to use the same admin credentials since they have access to everything, but you can create separate credentials for every single product. For this one specifically, we need full access to Amazon S3. So I'm just going to use those guys, this guy again. And there we go. Oh, wait, actually, just to make sure, yep. Okay, save. So we have that connection established as well, and we also need an EMR con ID. So I'm going to do EMR, Amazon Elastic MapReduce, great, and we're going to do the same thing again for EMR. You could have Elastic MapReduce role that has full access to EMR. We're going to just use this admin one for the sake of simplicity. So login and the password again and save. And now we're going to start setting up some variables. So those were connection IDs. Now we're going to go to the variable section. We're going to click plus, and we're going to set up a variable called climate data path. And as you may imagine, this is the path that contains climate data, obviously. And right now, I actually stored my climate data within this OneDrive URL. You can use that as well. So we're going to save this now. It's on the README file as an example. The second thing we need to set up is a region name. So we're going to set up a region name right now. Same one as previously listed, US East 1. Nice. We need a bucket name. So the bucket name, mine may be different from yours, so be mindful. My bucket name here is actually, we can go to the Terraform setup and check that out. So Terraform, and then the bucket name for me, it will be job and market pipeline. All right. And wait. Oh wait, let me reopen Visual Studio Code here on the side. Then we need to specify, so yeah, obviously this is the bucket where we're gonna store all the data from this process, from like all the scrapers, and also the climate data. So the climate data will be moved from OneDrive to this bucket. So next up we have the Aws Batch array size. And because this is a demo, I'm gonna just specify 2, which is the lowest valid number. And we also have Aws Batch number of threads. So batch size basically specifies the number of workers per scraper. So let's say the team blind scraper will run with 2 batch workers, 2 Aws batch workers. And we can also specify the number of threads. So per worker, we're gonna have 2 threads. You can also change this and customize it. We also have Aws Batch retry. So in case, so this variable is useful in case we fail scraping a company. So how many retries are we going to do in a specific URL? In this case, we're going to just do 1. And then we also have some other variables that will cover our proxies. So in order to reach out to Team Blind or Levels.fyi, we actually have a list of proxies that you can find more over here. So if we navigate to Airflow, to the Airflow folder, you should go to, Airflow Batch job, and then you have proxy stats. So we have a bunch of IPs here, and those IPs are proxy servers that are tunneling our traffic. They require a username and password. However, because we're running on debug mode, we don't need a proxy to be set up. So I'm going to set up the variable so it exists, but we don't actually need it in the case of this demo. But in case you have a list of proxies that you're using on the proxy's text file, make sure to specify the username and password to reach out to those IPs and be authenticated. So proxy username and save. We don't need to put anything here. Then next one will be, let's go back here. The next one will be the proxy password, obviously. And we also don't need to specify anything. Then we also have this empty variable called the job market DAG execution date. So this variable will be automatically populated by the DAG, but we're going to create it empty right here just so we know that it exists. But as soon as the DAG executes, like the first step will actually populate this with the current dates, the month, the day, and the year. And finally, we have an optional variable called debug DAG, and we're definitely going to mark this as true because we're running this in a debug setup. Otherwise, the DAG will take about 12 hours plus to execute, and we don't want that. So there we go. We have all the variables set up. That's great. So we can just go back to DAGs, and we no longer see the error there because we populated the necessary variables to run the DAG, which is awesome. We can go and we can search for job market as a tag, and we should see our job market DAG. If we click it, we can go to the graph section here, and we can see the whole, the complete DAG here, start job, getting information from Team Blind, getting the company's getting the company's list from Team Blind, also getting the climate data from the URL that we specified on the variable, running the ETL job, everything that was specified and we chatted about during the architecture review is being covered here. So let's go back to the DAG section, and next up we're going to run this DAG. So I'm going to cut here and we're going to run right next. All right. So actually, even before running the pipeline, we're actually going to go back to admin variables, and we actually don't need the proxy username, so we can totally delete this because we're running on debug mode, and we also don't need the proxy password, so we're going to delete this as well. Finally, we can go back to DAGs, and here on the right side we have a play button. We're going to click on that to trigger the DAG, and we should see this green circle that points out that the DAG is running. Let's click on that, job market, and let's just see what happens now. So the first step, as pointed out in the architectural review, is the DAG will execute 2 task groups in parallel. The first one will get some climate data, which is a big CSV file, and this CSV file is located in the variable that we just specified in the previous step. It will fetch this data in CSV, convert it to Parquet, and push it to S3. So we should see it pop in here in any second. After doing that, it actually checks to see if the Parquet file was successfully created, and if the file is, if it has any content inside of it. Okay, so we just created the file, so we can refresh here. We have climate data, and obviously it's not empty. We have 36 megabytes. That's great. And the second process that is running here is the thin blind scraper. So because we're in debug mode, if we click here really quick, we're going to notice that the thin blind scraper is actually just scraping a very small set of companies, which start with companies that have the letter A twice, and that's pretty much what it is. So let's just go back to DAGs and go back to our execution here really quick. So this part is pretty much done, and if we open S3, we should now see that we also have a companies folder which contains all the thin blind companies in Parquet format, and that's great. Then we have this join operator. This is a dummy operator, and now we're kicking off two other task groups. So the first one is going to Levels.fyi, and the second one is going to thin blind to scrape some data. Both of those steps are running, however, on Aws Batch. So if we open Aws really quick right now, we can go to Batch, and within Batch we can go to Jobs, and we can select the queue. So thin blind is going to be the first one, and we have this pending job here. If we click on it, we have two workers, just like we specified in the variables a second ago. And if we go to Levels.fyi, we also have a pending job here, which also has two workers running. So if we click on any of those jobs, it's actually pretty cool. You can see live logs from CloudWatch. And yeah, it takes a while because I think the container just started running, but eventually it actually gives you some logs. So let's just wait for a bit here. All right, let's see if we have some logs from the other container here. One. Nope. And from container 0. Okay, we have nothing yet. It's still booting up the containers, but eventually we get some execution logs, which is pretty cool. Oh, there you go. So in this case here, all those scrapers are running on debug mode, so they are just scraping the company Google. So this is what we found about Google here, and that's pretty much it. We're pushing that data again back to S3. So if we refresh this here, so this is one of the workers, right? We have two workers per task, so both of them need to finish. However, if we go to S3 right now, we should be able to see some new files popping up. There you go. We have a Levels.fyi folder with the current dates and both workers here. So this is the successful companies that we scraped. So Google is inside of this success.parquet file, and inside one we have the same company, Google. That's great. And our fail file is 1 kilobyte because it's just a simple Parquet file. It doesn't contain there's no content here. All right, so if we go back here, we should notice that the Levels.fyi part is already done, but we're still running the thin blind job. So that one takes a little bit longer, so let's just wait for it. Go back here to jobs. Let's go for thin blind, refresh this, and pending. And over here we can click again a job index, and we can see what's going on here. There you go. Oh, okay, so it was actually able to scrape Google. Nice. I think it just scraped Google as well. Or actually, I think it's still scraping Google, to be honest. So we just need to wait for it to execute. And the thin blind one takes a little bit longer, but yeah, it's gonna get done in a second. We can go back to the logs. Right, we can also go to the other container really quick. I think 0 and 1, right? Oh, so this one here succeeded. That's nice. So one of the containers just finished. That's great. So we found information about Google, Now we can actually go to S3 and we should see a new folder popping up called Team Blind. There we go. And within Team Blind we have the dates, and we have both workers. Oh, both workers actually finished. So we have 9 kilobytes of information about Google and 9 kilobytes here as well. Again, the fail parquet file is for companies that we failed to scrape, and this is going to be turned into a delta table along the road as well, so we can analyze what happened with our scrapers. So if we refresh here now we're going to the last part of this pipeline, which is the ETL job. So the first step is to push this bootstrap script and this ETL script to S3. So where are those scripts located, you may ask? So they are located within DAG's scripts, so bootstrap. And so bootstrap will basically get a bunch of Delta libraries for us. So Delta Core, Delta Storage, Hadoop AWS, and AWS Java SDK bundle. And also it will copy all of those to the user lib Spark jar inside of our EMR cluster. And the second file that we're pushing inside, so this file will set up the necessary libraries for the cluster. The second one is the actual Python script, the ETL job that we're going to run within EMR. And this job will be responsible for converting all the Parquet files into Delta files, into Delta tables. So we can just wait here. And it's creating the EMR cluster, so let's just check that right now. So we should go and navigate to AWS again. And then we can go to EMR. And there we go, we have a cluster that just started. Nice. And EMR takes a little bit longer to provision. So it needs to provision, and then it will run our bootstrap script. So it needs to download all the necessary libraries. And then after that, it will actually run something called the steps. So the steps, in this case, we only have a single step, which is our ETL Python script. So it will just run this step. And after it finishes running, we're going to terminate the cluster. So going back to S3, let me go back to S3 for a second. We should see after this gets executed successfully. So, so here now we have a scripts folder because we pushed the scripts locally to S3, and this is necessary for EMR to consume those scripts. So we have Bootstrap and ETL here. They were just pushed. And as soon as the EMR process gets complete successfully within Team Blind and within our current dates, we should see a new folder popping up. Actually, within Team Blind, we should see a Delta folder popping up as well. So we're going to just wait for a bit and come back and check that folder. All right, so the ETL job just finished executing. If we actually navigate to the EMR console here, we can refresh this. We're going to see that the task is now completed. We can even look at the logs for the task here. And the task is basically creating the Delta tables that I've mentioned. So we can see a snippet of those tables here. This is the climate table. This is the companies table from the initial step. From the second task group from Team Blind. So just a sample of records here. Then we have the Team Blind company success Delta table, and we have some duplicated results because we had multiple jobs querying for the same company, and we also have Levels.fyi here, which contains all the details from Levels.fyi for Google, and that's pretty much it. So now that we have this information accessible for us, we can actually go here on, we can actually check S3 first. So we're going to go to, where is it? Oh, there you go. We can go to S3, and again, if we go back and we refresh, we're going to see an EMR logs folder as well, which contains the logs for our steps and the container itself. So let's go back. But the interesting part comes within the Team Blind and the Levels.fyi folder. So if we click, I click the Team Blinds folder, now I can see a Team Blind company success Delta table. That's awesome. and which obviously contains all the data for those for Google in this case. And then if I also move to Levels.fyi, we also have a Levels.fyi company success delta table, and it also contains the data for Google, but again within Levels.fyi. And we don't have a fail table for those because we didn't have any fail records, so we don't need to create an empty table for that. We can also go to the companies folder, which contains the list of companies that we got from Team Blind, and we also have a companies delta table here. That's awesome. So we have all those tables, and they're all laid here. Also, we have the climate delta table that was created from the EMR job, and that's sweet. We have everything here. Now we're able to go back to our Jupyter lab, again locally on port 8888, and we have this analytics Jupyter notebook. And this Jupyter notebook will basically, we first need to install Delta Spark, so I'm going to just run this here really quick. And as this is running, like, we can analyze the other cells. The first one will inject some credentials that will be used by by Spark itself, and specifically to access S3. And then the next step will be defining this load table function, which will obviously load our tables. So we're going to provide a path for the table. So the table path here, for example, Levels.fyi, it's located at this bucket name and at Levels.fyi, and then the table name. Anyways, it's basically providing the path in S3. We can load the table with the path and the table name, and when we load them, it actually creates the table locally in memory using the location in S3, so the delta table location, and then we can run SQL statements on it, right? Okay, so we have delta installed. We need to inject our current credentials, so let me just, oh, I have it here actually, so let me just copy this, and let me go here, and I'm going to copy this here as well. And there we go, save, and we can run this now. And we're going to run PySpark, should run successfully. Just wait for a bit. We also can run this cell here to declare our load table function. And you guys can see that from the previous run, I actually have, I had loaded this table before with another data set from the 12th. Now we are on the 13th, and we can see some interesting queries. We're going to navigate to those. Okay, there we go. So the cells ran successfully. So before we load the current tables that we have, we're actually going to look down here and see some of the interesting queries we can execute. So for example, if I want to know which companies have the best work-life balance overall, I can literally do a select on the Team Blind table. So this guy over here. Again, this is the delta table that we just loaded over here, here. And we can select it, we can inner join it with the Levels.fyi table, and we're inner joining by company name, and we're looking for companies with work-life balance greater than 3. We can order by work-life balance, and we're limiting for 12 results, and there we go. We have the companies that have best work-life balance within Team Blind. And also we can connect that with Levels.fyi in case we want extra data about compensation, right? So another question we may ask is, which companies have the best work-life balance in my city, right? So the city in question here will be San Francisco. And so we're looking for, again, company, work-life balance, locations, which comes from the Team Blind side. And we're going to also look on the Levels.fyi. We're going to look for L4, which is one of the levels that is common in those companies. Like, it's an entry-level engineer, so we can look at the Team Blind table. We can inner join it with Levels.fyi using the company. Then we can filter by work-life balance greater than 3.0. And location, we're doing a light query here for San Fran, and we're ordering by work-life balance, and we're getting 5 results, right? So there you go. Those are the 5 companies within San Francisco with like work-life balance greater than 3.0, and we're ordering descending, so we have the top ones here first, 4.5, and we even have some enhanced information about the compensation for the L4 level for mixed panel. And you can imagine there's other queries like which companies have the best compensation overall. We can also do inner joins here. We're looking for compensation greater than 4. We can order for it, and now we know like Netflix pays really well, Roblox, Discord plays extremely well, and again we have mixed panel and etc. Right? And finally, we can even look for which companies have the high career growth in San Francisco. And additionally, let's also fetch the temperature of that city. So now we're going to use the climate data set as well. And there we go. We can do a select inner join with the climate table, and we can concat by city. And we're looking for career growth greater than 4.5. So this is amazing career growth. Location for the team blinds table will be San Francisco, CA. And for the climate table will be San Francisco. And then we can order by descending order 5, and there you go. So we know like the last recorded dates climate like that we have. We know the average temperature of San Francisco, and we also know the companies with great career growth. So let's say I want to work in a city that has amazing career growth, and I also like the climate of the city, of the headquarters, right, where the headquarters is located. So this is all pretty powerful. Again, this is all in data that was already ran from a previous data set, but now that we have our own data set, again, it's pretty small, but we could still be able to run this as well, and I'm going to show this right now. So we're going to load those tables first. Oh, okay, so load table. Oh yeah, okay, so we got to change the date here. We are on the 13th, no longer the 12th, so let's see if it works now. And let's see what we get there. There you go. We start getting some tables back. So this is Google, and this is the comps for Google. And we also have the team blind information for Google, which is pretty nice. And finally, we have the climate data information. Again, we're just putting a single row just to show that the table was created successfully. Obviously now we can run those queries again, but they're not going to be that meaningful, so let's just run them. So the first one will select, yeah, we only find Google, that's okay. But just to show that, yeah, like we can run all of them actually. Oh, we don't, this one obviously didn't work. And there you have it. So yeah, that's pretty much it. So with this Jupyter Notebook, again, this is running locally. You can also have a Jupyter Notebook within EMR in AWS in case you want more horsepower. There's also Jupyter Notebooks that you can spin within SageMaker, but we're running this one locally and we're able to analyze our data set further. So this is our demo for today. This is the pipeline fully running locally. We can also run Airflow remotely with the managed Airflow service from AWS. But running this locally, it's much easier to debug in our case, and also cheaper, right? So that's the demo. Thanks for watching.